Okay, we're going to make the robot turn right autonomously. So we're going to create a new op mode. We're going to call it right turn. And we're going to set it to autonomous. We're going to get rid of this little tooltip here. Just click on the question mark and it'll go away. Okay, so I want to make this as general as possible so that if you want to change the amount of right turn, all you have to do is go in and change basically one or two numbers. So the first thing we're going to do is we're going to set up our motor. So we're going to do some initialization. We're going to do the standard business with our two motors. We're going to set the left motor direction to reverse, so that when power is applied to both of them, you'll go forward. And then what we want to do is we're going to do this all by counting ticks of the encoder. So to count ticks of the encoder, we need to stop the encoder and reset it to 0. So there is an option here to set the mode. So let's put this here. And I want to set the left mode. My motors are called left and right. So this is my left motor. And I want its run mode to be to stop and reset the encoder. Okay, so it'll set the encoder to 0. And then I want to make a copy of this, and I want to do the same thing for the right motor. So we'll just go up here and we'll just change that to right. And this will reset both of them, so our encoders will be starting to count their ticks at 0. Okay. And now what we're going to do is we're going to set up some constants. So I need a few variables here. So let's create some variables. One variable is going to be the number of ticks per motor revolution. Okay. And another variable is going to be the circumference of my wheel. So we're going to call it wheel circumference. And I'm also going to figure out the number of ticks per inch from those two numbers. Okay, now let's set the values of some of those variables. So I want to do a few set commands right here. And actually I'm going to do 3 of them because I've got 3 variables here. So I'm going to duplicate it, and then I'm going to duplicate it again. The first thing I want to set is I want ticks per motor revolution. And we need a math constant for that, so let's drop that in there. And this is going to vary depending on your motor. The motor I'm using is 1,440 ticks per revolution. And the next thing I want is I want to set my wheel circumference, and this is going to vary depending on the size of your wheels. And I am doing inches here. And I measured the circumference of my wheel, and it is 12.6 inches. Okay, and then ticks per inch is just going to be the number of ticks per revolution divided by the number of inches per revolution, and that'll give me ticks per inch. So this is going to be a division problem. So let's take our math and tell it we want to do division. And what I want to divide is I want to get a variable here, and the variable I want is ticks per motor revolution. And I want to divide that by the wheel circumference. And that'll tell me how many ticks per inch. And then all you have to do is figure out how many ticks do you want to travel, how many inches do you want to travel, multiply that by the number of ticks per inch, and plug those numbers in, and you should be able to get your robot to travel pretty close to the exact number of inches that you want it to travel. Now we're doing a turn here, so we're going to have one wheel going one direction and one going the other. And that's going to be a little bit trickier to calculate, and I recommend just doing a little bit of trial and error here to see how much you need to turn in order to get a 90-degree turn. Okay, so we need to figure out how far we want the wheels to turn, and I really don't know what that number is. So I think we're doing a trial and error thing here. So what I want to do is I want to figure out number of ticks to travel. So I need a new variable here. So I'm going to call that ticks to travel. And I want to set that to the number of inches that I want to travel, and I need another variable for that. So let's create a variable called inches to travel. And I want to set inches to travel to, let's do a small number like 4 inches. Okay, so let's go to math, do a constant, and travel 4 inches. And then the number of ticks to travel is going to be 4 inches times the number of ticks per inch. So that's going to be a multiplication problem. So let's go back to math here. And let's select multiply, and we'll drop it in here. And I need a variable, and the variable is going to be ticks per inch times inches to travel. So inches to travel is one of them. And the other variable is ticks per inch. Then what I have to do is I have to set my encoder to travel that far. So we're setting something called a target position. And let's go to our motors here, and let's go to dual. And we want to set a target position for my left wheel and for my right wheel. And I want that to be the number of ticks to travel. So let's go to my variables here and get ticks to travel. And I want both of them to travel the same distance. So let's go back and get ticks to travel again. But I want the right one to go backwards. So I want that to go a negative tick. So it counts backwards if we're going in reverse. So let's go back to math here, and I need to put a minus sign in front of that. So let's go here and let's just put the minus sign. And okay, so now we've got the right one going backwards and the left one going forwards. And we need some power to the wheels here. So let's add some power. So we'll set the power down here. So let's go to our DC motors here. And let's go to dual, and let's set the power. And while we're trying this out here, let's make it turn kind of slowly. So we'll do half power. And then what I want to do is I want to turn my wheels repeatedly. So I've got a loop here, and I actually don't have to put anything in here. All I have to do is tell it that I want to keep on repeating as long as the left motor is busy and the right motor is busy. And the motors will be busy until they get to their destination, which reminds me of one more thing that I need to set here. I need to change the run mode. So let's go, that has to be done up here ahead of time. So let's go back here to do dual. Can we set to run mode? Yes, we want to set to run mode for run to position. And that will run to the target position that we set up here. Okay. And okay, now all we want to do is we just want to go here and change our while loop. So our while loop is going to be as long as left is busy or right is busy, and that's up here under our motors, way down here at the bottom. So let's go over here and drag that and put that in. Whoops, no. There's two conditions. I want it to do as long as the left is busy or the right is busy. And, they should be busy for the same amount of time, but if they're off by just a little bit, this will make sure that they both travel the correct number of ticks. And we need an OR condition in there, so that's going to be logic. So we're doing a compound condition here, and it's going to be OR instead of AND. And I want to do that while, whoops, I missed. Let's try that again. While left is busy, and then I'm going to duplicate this, and I'm going to put it up here, and I'm going to check or right is busy. And I don't need this anymore, so I can delete it. And now we're ready to test our program. So I tested the program, and I had to set inches to travel to a slightly bigger number than I thought I was going to have to. And this will probably vary depending on the surface that you're on. I'm doing this not on a mat right now, but I'm doing this on a carpet. And so by trial and error, I figured out that if I have each one turn 11 inches, that I will get almost exactly a perfect right angle turning to the right. And if you want to turn to the left, you would do exactly the same thing, except you would turn your wheel directions around, and you could do a 90-degree turn to the left. So the key right here is, once you've got all this set up with these variables here, then the key is just figuring out how far you want to travel to make the particular turn, and that's just something you can do with trial and error.